Hi everybody, welcome to this third lecture. First of all, I want to talk about check your naming conventions because this still happens quite a lot. Some issues with that. So the assignment we had last week was to create a basic Greek temple. Like always, it's important to check all the videos that I've created for this so that you know what you're dealing with and that you're prepared for the current class. The scene names for both the scene and the RAR files, like I said, you'll find it right over here. And sending by email is okay, since the files are most of the times very small or small enough. So today, what are we going to talk about? We're going to talk about normalizing. Normalizing, like I say over here, is setting to a unit length. It's making sure that everything is easy to work with. And that you don't have to deal with awkward numbers. Now there of course don't exist awkward numbers, but it's a way that you can measure up things in a very easy way. So what's the process basically of normalizing something? If you take over here these numbers, 1 divided by 1 gives you 1. If you divide 0.74 by 0.74, again you get 1. So now this value is getting normalized to a value of 1. Now what we have to do over here is to make sure that if we create an object, for example, that we can always fit it within the dimensions 1, 1, 1. So whatever object that you're going to deal with is that you can fit it in something. Now the problem is we're dealing with geometry, we're dealing with actually a collection of points. Because we're not in the geometry level, but we are at the points level, the compound level, like you know it in Maya. And so scaling, if you want to scale something down to dimensions of 1, 1, 1, you have to do a different kind of method. So the formula to set this line to a size of 100 is the following. First you need to get it to a size from 0 to 1. Now it's a line from 0 to 8.75. So how can you scale it down that you get a line from 0 to 8.75 to a line from 0 to 1? And that's done by the following. This is the normalizing that you need to do for the scale. So you need to divide 1 by the current length or the current dimensions, and then times 100. So like this you get exactly the right scale number to scale this line up to an exact dimension of 100. So first normalizing it, and then it's very easy to set the exact dimension that you want to have. Now that's the same over here. If you want to use, for example, a curve, and you want to be very flexible, you want to use this curve in different dimensions and all those things, again you have to normalize the values until you get like 1, 1, 1. So this is something that you can use in many occasions. So it's for boxes, it's for everything, and it's also even so that it's very useful, for example, with images, with compositing. Now with images you have to do something else. You have to just divide the color by its own mask, for example. Now here there's an example. If you have like a motion blurred image, and you divide it by its mask, you get a shape like this. And this shape allows you to give good and correct color correction. And after you've done the color correction, you can then again multiply with the mask, and then you have again your proper image. But this is the only way how you can do proper color correction, because over here, if you do color correction on this level, every part of this is going to react a bit differently. So let me show you in an example. This was done by a divided image, that we had color corrected, and then again multiplied with its alpha mask. And over here we did the same operation, but without using the divide of the alpha mask. And you can clearly see the result, that at the end right here we have like this black outline. And this is especially true if you just want to composite like several layers with some adjustments. In several occasions you will notice that you will have, with this anti-aliasing, some offset looking colors. Most of the time you have like these black outlines, and that's not very beautiful. So if you approach your compositing each time this way, it's gonna help you out to create much better images. So why do we normalize? It's because of the same reason that they've created the metric system, so that it's easy to convert from one to another and to use it in all kinds of ways. Okay, so we're gonna start with some exercises, and we start off with something very simple. So we have this box over here, and we have a transform. So what we're gonna do right now is we're gonna make sure that this box has like all kinds of different dimensions. And the idea right now is that you're able to normalize this shape so that it becomes a shape that fits back in exactly a box which is of the dimensions 1, 1, 1. So since this box is going to sit in the middle right here, it's going to be starting from this point till this point, from this point to this point, from this point to this point. So try to write down the proper expression over here in the X form, so that its scales down exactly to what you need. Do that now. Okay, so when you done that, you can add something else. For example, add another transform. Now, if you've done it correctly, you should see that if I add some extra scaling on top of this, the shape should still be normalized without any problem. So again, try to solve this puzzle. If you think of another method, pause the video here. If it's still working, you can continue. Okay, let's make it just a little bit more difficult. I'm going to add a point jitter right over here, and this is going to deform the whole shape. So now still the solutions should work. Now the idea is that with this point jitter, that your shape is of course not going to become a cube, but what should happen is that this whole shape is going to be scaled down so that it fits exactly again within these cube dimensions. So try this now, and you can pause the video again. So I will show you the proper methods that you can do. So what you need to do is actually you need to measure up the size of the whole object, and then make sure that you divide one by its size. So you can do that very easily if you check the help file over here. Again, you check the local variables, and you see right here all the dimensions that you can obtain. For example, size X, size Y, and size Z. So it's again always important to check what local variables you have. So it's not always necessary to immediately jump in and use the bounding box expression. Now another thing that a lot of people might have done is that you've added channels over here, so that you directly wanted to connect from the box to the X form. And what they did to solve the second problem was to connect the channels from the box to the X-form, and then from X-form to also the channels, and try to make like this very complex expression in order to solve this. But the idea is that at all times you should be free to throw in whatever object there is, like for example a sphere. And let me just show you what this is going to look like, polygon. So if we do it the proper way, using 1 divided by dollar size x, and we're going to copy this, size y, size z. So now we have a box which is nicely fitting within those dimensions. Now there's still one problem, and that's something I'm going to address later, is that as you can see this object is not fitting exactly into the center. This is also something that you can do in one go over here, but let's first check everything, so whether it fits nicely. So whatever dimension that I use over here, you will also see that when it's out here it will be in right here, and the same over here, it will be out like this. So as you can see it more or less already that this object is nicely fitting within the one dimension. And so even if I change it to a sphere, it will also do that exactly as we expected. Now the thing is, we need to get this object into the center, so that it's not only nicely formed in dimensions, but that it's also in a very easy to access place. So what can we do? For example, right here in the translate you have to do something, and I'll give you a tip. It has to do about the centroid of the object that you need to place back to this position of 0, 0, 0. Another tip I can give to you that is in operation quite similar to what we have done by putting the box with the previous courses, putting the box onto the ground at all times. So it looks kind of like it. So pause the video if you want to do this. If you're ready for it, you can continue. Okay, so here comes the solution. So it's just by subtracting the centroid $CEX again, and this is a variable that you can find within the help file of this specific node. Now you will notice something else. Although we've done the correct operation over here, you will still notice that the object is not centered. So it's still jumping around. Now, why would this be? I'll give you a clue. The way of solving it lies somewhat in one of the buttons that you can click over here. Let's try to fix this. Okay, I'll give you the solution and the reason why. Scale, rotate, translate. This is the order of transformation. The problem is that it's going to check from the previous node how much it needs to move and how much it needs to scale. Now, if the scaling happens first, this means if an object, for example, is sitting over here and it's being scaled, then it's scaling towards the pivot point 0, 0, 0. Now you might have added, like over here, the centroid of the object for the pivot point, but we're not going to do this. So if an object would be standing over here and you would scale it down, then it would scale down, for example, to this position. Now in that case, if you scale first, the centroid of this object is going to change. but the value that it's getting is from the previous one, so that is not being adapted, so the offset is then going to be too big, and that's what we're seeing right now. So again, if we see when changing points, we see this object jumping around all the time. The reason is because it's got scaled first and then being offset, and this doesn't give you the proper result. So what you need to do is to make sure that the translation becomes or happens before the scaling first. So we're going to translate, rotate and scale like this, and now you'll see whatever we do that this object is fitting nicely always inside. So whatever object that you have, as you can see with this box, also this one is always fitting nicely inside. So what could it be good for? For example, right now it's for me very easy to tell which position this object should be. So for example, I can put it right over here at position of 3, and I give the scale of 5 in height and perhaps 2.5 to move up. So as you can see, this object is always resting on the ground and it's always fitting nicely. Whatever I do, even if I take for example a torus, which is this, how can I put it, stranger shape, also this torus is nicely going to fit. So let me switch off one of these nodes. Again, you see this torus fitting nicely. I can even start to rotate this torus, and as you see, it will always try to fit the whole shape within the dimensions we've set. So this is normalizing. Right, I've given you an example on how to do normalization with using a curve, and so this is exactly what we're going to do right now. So you can follow over here and I will explain. So what we're going to do is we're going to take a box and I'm going to make it again the default dimensions, and I'm going to copy this box over a line. So just creating a line over here, and the distance of this line is about 10, and I will add 10 points with this onto this line. The reason why I have a distance of 10 is that by default these boxes will have enough spacing right over here. So we see all these boxes placed nicely. Now the thing that I'm going to do is I'm going to add an extra channel over here, a channel that we're going to use to create our curve that we can use to deform our boxes right here. So if you want to add channels, you can go over here to this gear and edit the parameter interface. Let's close these folders so that we have a better view. You drag in a folder and you can give it a name, for example my controls, and in those controls make sure to drag it in. You can add over here a parameter, and so we're gonna call this a curve size, C size. Make sure you always give your parameter its own specific name. This is the name that you really need in order to make your expressions work. This is a label, and this label is just for you to make sure that you understand what's going on. So if you apply this, you see right here the tab My Controls, and I see this readable name curve size, but if I leave my mouse on top of it, you see the parameter name, which is C size. So what we're going to do right now is we're going to create two keys. One key at frame 1, and we do this by pressing Alt left mouse button over here. You see it will turn up green, and if you click on the name you will see that it has a Bezier name, or that the expression is Bezier. Go to 100 and do this again, Alt click. So now we've created two keys, and the reason why we've added keys from 1 to 100 is that I need to have enough resolution of my curve. If I would create a key from 0 to 1 immediately, then the problem would be that my curve would not have enough detail. It would be downsampled and you would have like this very blocky curve, and that's something we can't use. So you need to have enough resolution in your animation curve. Now if you press shift on the curve size, you go over here and we see right here our curve. Make sure that you move using the space bar, because if you don't, you start adding keys if you use it the Maya way. Now there are two ways how to manipulate these handles. You have these boxes and you have these lines. If you take the boxes, you can move in the height, you can change the values like this. If you take the lines, you can move in time. So they give you a little bit separate control. The handles are immediate Bezier, so you can start changing them immediately like that. You don't have to change them afterwards. So create a curve something more or less like this. Okay, so the next step that we need to do is we need to read these parameters out, and we need to do this in the stamp value, because we're gonna stamp the channel that we read on each one of those boxes. So switch on stamp inputs. Again, this is very important. And we're gonna first try to read the channel. Now the channel, since it is within this node, we don't have to add like these points. We don't have to go outside of this node. We stay inside this node, and I'm going to type exactly the name parameter. So channel size is the name of the parameter, and my variable name is copy. So for each copy I'm going to do this. Okay, so to apply the stamp name, add a transform node. Never use the stamping within the copy node. You're never gonna use it over here. This is very important. Stamping is always used on the part of the graph which is controlled by the copy. So keep this in mind. So for the scaling, let's use a uniform scale right over here. And I'm going to add stamp quotes. First of all, I need to get my copy node where I want to get my stamp information from. Then the stamping name. Copy. And then the default value if it can't find the stamp name. So now we have this scale. We see that our boxes have been adjusted. So the result that we have right now is, since we just read out a channel, it's going to take the curve as an animation curve. So if we move the time slider, we see all these boxes are adjusted. And this is not what we want. We want to make sure that we adjust each one of those boxes individually. Now, like I said, we have this curve going from 0 to 100. And we have right now 10 objects. Let's make it just a little bit more. Let's make it 14 points. Or 13 points, whatever, doesn't matter. Or 12. The thing is, this number of points that we have, we want to divide them equally over the curve to sample this. So let me go back by left clicking. So these 11 samples, I need to pick them right over here, nicely divided over this whole length of 100. So again, what we need to do is we need to normalize the total number of points that we have over here. And the other thing that we need to do, we need to read out this channel, and we need to read out this channel and be able to specify exactly which part that we need to sample. So for this, you will have to use a different kind of expression, channel F. So again, check this expression in your help file, the channel F expression. It will give you more of an idea of what it does. So what we see over here is, first of all, we need the string channel, the channel that we need to sample, and then the float frame, and this is the number that you need in order to take the sample. For example, if you want to have like the last part of your curve, the float frame number is 100 in this case, because we have set our curve from 1 to 100. So again, C size, and I'm going to add over here each sampling point. So the thing which is going to do now is each point that we have is going to use its own ID, its own number, to start sampling on this curve. So what do we see over here? We start off with like these very small boxes which gradually grow. And the reason is why we see something is that we have sampled again. Yep. Come on. It's hidden over here. Is that we have sampled from 1 to 12. So you see we have already this part of this curve. 12 objects and so on. So you will see if I increase the number of points, you see this curve is already starting to work. Now the thing is, like I said, we need to make sure that we fit the whole thing in. So first we need to normalize the whole thing. And how can we normalize? We can normalize by dividing the current processed points by the total number of points. So this means if we take the last point and we divide the last point by the total number of points, we're going to get 1 in the end. So the last point would be point, let's say 12, and the total number of points would be 13 in this case. I will explain to you immediately what it is. $NPT minus 1 needs to be added first. Now, why this one minus 1? Well, the reason for this is simple. Minus 1 is because we have over here point numbers, and their point numbers, they start always from 0. So this is the first point starting from 0. But if you count the number of points, you will have more points. So you will see you have 0 to 17, but if we middle mouse button click over here, you see we have 18 points. So that's why you need to make sure that you subtract 1 point from the total number of points so that you have like a proper division. And then at the end you have to multiply by 100 in order to make sure that we fit the dimensions of our curve that we've created. So press enter, and now we see that we have our curve nicely fitting the whole thing. So now it doesn't matter how many points that we have, it will always fit those dimensions. And what we can do right now is we can start playing with this curve. And you can see that you have like easy control. So if you press Alt, you can add some extra controls over here. And so you can create like special animations or other special tools. All kinds of things. Now the next step that you will need to do is the following. Let me just open one of these recent files, the for loop copy. Nope, this is not the one I was looking for. NHTV courses. Lecture 3 2012, and what we have over here, curve control. So this is a bit of a challenge. So we have a box. We have a delete node to make sure that we discard the first box and that all the boxes are being influenced. We have a for each node this time, and we use this for each node to stack all the boxes on top of each other. And we have like 3 curves. I created one curve for adjusting the width, one for adjusting the height, and one for adjusting the angle. So if I take, for example, this one for the height and I add an alt right here, or for the width, you can see that I can easily create some other shapes. If I go, for example, to the height, again I can use this to add some extra shape in it. And as you can see, the boxes will always be stacked nicely on top of each other. So this is the idea, that you solve this. So you can pause the video right now and you can try to solve this. Okay, let me give you the solution to the following problem. And that's like this. First of all, we take this default box. I'll make a copy of this. Let's create a for each loop. First thing that I will do in for each loop is set this to each number, so I have control of the number range. The index stamp name is the one that gives you the iterations. So we're going to give this also the copy name. So as we see over here, if you middle mouse button click, you see the iterations for last cook, and these are 10 iterations. So this index stamp name is going to give the stamp each time a number, starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have something which we can use for each box to do something. Let's go in here. We have our 2 connections. We see our box coming in over here, our box coming in over here. So first we're gonna stack our boxes. Add a transform node. And we're gonna merge the result together. Now the way how we're going to stack is to read out the each one and to make sure that the incoming box is resting on the ground. So first we do minus $y minus, so we take the minimum value, put it over here, and then we're going to add this on top of the bounding box of the each node. And we're going to use for that the y max. If we merge this together, we see one is stacked on top of the other. Now, like in previous videos, we have this done 10 times over, so we have like multiple objects over here, so we need to switch off merge results so that everything is stacked on top of each other. Now make sure that we delete the first box because we want to have everything stacked nicely on top of each other, so delete. And we're going to delete everything, so this is saying not everything. So we're going to delete the not. Okay, so all these boxes are stacked right now. So next step is adding the channels. So again we go to this gear, edit parameter interface. And the parameter interface, we find over here like multiple of these things. Well, we're gonna put our values over here. I'm not going to add an extra tab in this case. So 3 floats, label them copy curve width, curve width, curve height, and see angle, curve angle. So make sure to accept this, and we'll see over here our 3 values. So I'm going to create keys for each one of them on frame 100, and on frame 0 I'm going to do this as well. So right now we have our curves properly put over there. We're gonna create for each one of them like a set of different values. Something like this. I like that I have full control. Let me change the angle to something like this. Right. So if we now go to the for each node, what we need to do is we need to add again a new transform, because we're going to use this transform always to put the boxes in the end onto the ground. So use transform, and now we need to do exactly the same principle. Now the reason why I put this transform on top of this is that I want to do all kinds of operations and then stack. So it's important to do it always above and keep this one as last. So first of all, I'm going to change the height. So again, we're going to use a channel F, and we have to get to the root. Now I'm going to give you a little bit a shorter version how you can get to the root. If you just click double points, you will see that we're outside in this space. So this means that we're in the for each dimension and that we can access all of its parameters just directly over here. So the ones that we want to use over here don't show up immediately, which is a bit strange. Let's see, like this. Well, it seems that they don't show. I have no clue why this is. And the reason is because I've created them on the wrong spot. I created them on the delete. Well, in fact it doesn't matter. I did it a bit strangely. You can also do this from the delete node, but it's better of course to do it from the for each node. I just wasn't paying any attention over here. I was just over here. But okay, let's go to the delete node. So we do it this way. Go up one more time. Go to the delete node, and then there we can find the ones that we've created. So we're gonna start with C height. So now I need to get each dimension over here, each iteration. So right here we use the stamp. I have to go up to this node. Now if I do just double point, like I said before, I'm at the for each node. I take my stamp name, which is copy, and then the 0 value. So now I have each iteration being used over here, starting from 0, 1, 2, 3, 4, till the number of iterations you have. So again, we need to normalize it by dividing it by the total number of iterations, which is something you can find in the node. It's number range 2 over here. Number range 1 is start number, the end number, and step size. So we need the end number over here. So this is the total number of iterations. So the current iteration divided by the total number of iterations times 100, and we close this. Now we will see, if we merge this all together, that I first need to activate what's over here, and you see the result. So I now have my controls over here, curve height, and so we can start adding extra keys, for example to scale parts down. So you can make this moving worm kind of behavior. Okay, so this is again a first step. So you can continue doing this same principle over again with all the other channels for rotation and for translation. Alright, so this is how you solve this whole equation. So again, to show you how to access all these channels, as you can see, the stamping, just double point and you get immediately to the right position over here. And the same is also over here with the angle, double point, and you get immediately all the controls that you need. Okay, so what we've done now is we handled the curve control, this one. Now I've last assignment that you can try to solve, which is also very important, and it's how to nest copy parameters. So the idea is the following, that you first use this very simple box or this very simple graph. So this is without adding an extra object to copy objects onto. So you will need to make, let's say for example, 10 copies, which using stamp are going to be randomly placed so that they have a position always from -1 to 1, and that they have a scale from 0.1 to 1. This is important. They're going to be placed more or less like this. The other thing which is quite important is that you use, for making sure that you have these positions and the scaling, that you use the fit expression. Now there are multiple fit expressions, so check them and read them in your help file. That's the first graph. Make sure that you solve this part first. The next part is that you're going to copy these things multiple times, but that each time they have their complete unique seed. So you have all these boxes being generated and they are all unique. This is very important. Okay, so you can start with it and pause the video right now. Right, I'm going to give you the solution to it. So first of all, you start with a box. You create a transform, because this is the transform that we're going to use, and we're going to create a copy node. So we're going to make 10 copies, and so we're going to read out the stamp inputs, and the value that we're going to use is $CY. If you check this in the help file, you will see what this variable is for. Make a copy, name as a variable, and so what we're going to do over here is we're going to change the translations, and we'll do this by random scale, random stamp copy 1, and the name of the variable is copy, and the default value is 0. So now we have in this direction random positions. Now what you need to make sure of is, instead of going from 0 to 1, that they go from -1 to 1. So for that we're going to use the fit function, fit, but I'm going to use a special one, fit 01. This will make it easier for me, because this fit 01 assumes that your initial values are going to lie between 0 and 1. So I only have to add 2 more values, to which one they're going to be extended. -1, 1. And close this over here. So now you see we have our randomness right in here. So we're gonna do this for all channels. Copy, paste it over here, paste it over here. Now as you can see, everything is still sitting on one line. So you have to make sure that each one of the randomness is being offset. Now what you can do over here is to add plus a number plus another number and plus again another number. It's best to use values which are quite high, so that the patterns are not going to intersect or interfere with each other. So this is one part. Now we have to do exactly the same with scaling. So what I'm going to do is, over here I'm going to copy this parameter and I'm going to paste the copied expressions over here. I will change the values, so I get again something which is totally different. Now our fit function is still not working because we have a minus value to a positive value, and so as you can see we've inverted the scale in some cases, but what we wanted to have was the 0.1 to 1 value. 0.1 to 1, 0.1 to 1. So now we have exactly what we need. That's the very first step. So now we're going to create a grid over here, and we're going to make its size big enough, let's say 40 by 40. So if I copy them, I'm going to have all these parts. Now as you can see, most of them, they are much lookalikes. Bring them just a bit closer. So I need to have random boxes everywhere over here. So what I'm going to do right here is going to the stamp, using $pt to get each number of this point, and I'm going to add it over here as a copy. Now we can add that on top of this one, or we can add it directly in the expressions. Now it's easier to add it right over here. So we're going to add plus the stamp of the copy 2 stamp copy 2 copy 0.0. Now you'll see there is a gradual change, but it is very gradual. It doesn't change enough. As you can see, you see this pattern, and it's as if this box is evolving into all these different shapes. So we need to break this pattern. Now how can you break this pattern? For example, you can multiply this whole thing with the number of points. So first thing that you need to do is to perhaps we can start with this. but we can multiply it over here with the total number of points. So for example, take the expression number of points, and I'm gonna get this from the grid. I think I've written a mistake over here, times the number of points. Grid 1, of course. And as you can see right now, each one of these objects is totally different right now. And that was the whole idea. So now you can get all these randomized shapes, and this is already start preparation for what you will need to do once you create your own Gribble. Well, you can start to fine-tune a few things. For example, what I don't like right now is that the dimensions are just a little bit too big in the translation, so we can make it 0.5. Oops. 0.5, 0.5, 0.5, 0.5, 0.5. So we have like nicer shapes over here, more compact. Let's display just a little bit differently. Make our grid size smaller, something like this perhaps, or just it's a bit too small. And you see we have our very first randomized stacking of all kinds of boxes, which starts to look a little bit already like some machinery. We almost start to get our Star Wars kind of shapes. Okay, this concludes this video lecture.